Hello everyone, how are you doing? We are back with another video on equations of straight lines. Let's get right into this problem. Looks kind of scary. We'll see just how scary this problem is. So it says the equations of the 5 lines are given below. We've got line A, B, C, D, and E. And the first question says, which line goes through the point 1, 9? Well, to do this, we simply substitute x as 1 and 9 as y because it's xy. So here we have 9 as y, so that's going to be 9, and we're comparing that to 2 lots of 1 plus 3. Does 2 times 1 plus 3 equal 9? No, it does not. So that one does not go through the line. Let's try the next one. We have 9 is equal, well, we don't even know if it's equal. We're going to put the equal sign and we'll put a slash right through it if it's not equal. A half lots of 1 minus 3. Well, half times 1 is a half. Take away 3, nowhere near 9. So, yoop, slash. Not this one. Let's try the next one. We've got 9 equals 6 minus 1. I'm just putting the ones in brackets to show where the substitution has been made. Well, that's not equal. So, yoop. And we've got x. Then we've got line D. Let's try that one. So, y is 9. And that's minus 2 lots of 1. Now, you've got y take away 2, because 2 lots of 1 is 2. So 9 take away 2 is 7. Yes, that is the one. And just because, we want to be sure, let's check for sure that the other one doesn't work. So let's try y is 9 plus 2 lots of 1. Well, that definitely doesn't equal 3. Yeah, so that one doesn't work. So in actual fact, it's line D. That's like the long approach to how you go through that question. Which 2 lines cross the y-axis at the same point? Okay, we're going to rewrite these in the form y equals mx plus c. So this one's fine. This one's fine. I'm just going to rewrite line C as y equals minus x plus 6, just so that we can clearly see where the y-intercept is. This other one as well, we're going to rewrite it as y equals, adding 2x to both sides gives you 2x plus 7. And then we can see the y-intercept there is 7. And then this one here, we can see if we rewrite it, we get y equals minus 2x plus 3. So we can see this one has a y-intercept of 3. Are there any other equations that have a y-intercept of 3? Yep, we've got this one down here. So which 2 lines cross the y-axis at the same point? Well, it's lines A and E. Line A, and we've got line E. Next question, which 2 lines are parallel? Now that we've written them all in the form y equals mx plus c, happy days because we can see the gradient. Well, we've got this first equation, its gradient is 2. So we need to look, are there any other equations with gradients of 2? Well, this one over here, line D has a gradient of 2. So they must be parallel to each other. So that's good. We're doing well. So of the 2 lines that are parallel, that's going to be line A, and we've got line D. And then it asks afterwards which 2 lines are perpendicular. So let's look at the first one again. The gradient is 2. That means our perpendicular is going to have a gradient of the negative reciprocal of 2. So 2 can be written as 2 over 1. The negative reciprocal is going to be minus a half. So do any of these equations have a gradient of minus a half? No. So that's not the one. So let's leave out line A. Okay, let's look at line B. That's got a gradient of a half. So let's find the negative reciprocal of a half. Well, a half goes to minus 2. Are there any ones with gradients of minus 2? And yes, it's line E. So that means that lines B and line E are perpendicular. So line B and was it line E that are perpendicular? Okay, so again, looked scary, but wasn't too scary. Again, I will go through as many examples as needed.